Section 5.3, we talk about special. Case factoring. So with special case factoring, there's 3 different types. So just to make this tree again. Oh, not that. Just to make the tree again, when we factor, first one is GCF. We've talked about that. Second one is grouping. We've talked about trinomials. The fourth one is special cases. And we build our way up. So we laid the foundation with GCFs. It seems like everyone gets that okay. GCFs were involved in grouping. Grouping was involved in trinomials. And now special cases kind of brings everything together. There are 3 different kinds of special cases. There's what's called the difference of perfect squares. There's a sum of perfect cubes. And then there's a difference of perfect cubes. So we'll go through these 3. First one I wanted to talk about is a difference of perfect squares. Difference of perfect squares says if you have something that's a perfect square, like 4 or 9 or 25 or x squared, if you have something squared minus something squared, the shortcut to factoring it is just to write the first term plus the second, and then the first term minus the second. I'll show you some examples. I just ask you to factor. What if we had x squared minus 4? So you just have to figure out what are we squaring to get x squared? Obviously x, right? What are we squaring to get 4? 2. So according to the formula, once you figure out what you're squaring, you just write x plus 2, x minus 2. That's all there is to it. What if you had 9a squared minus 16b squared? No, so we talked a little bit about this in the last class. If you remember the properties of exponents, 9, if you just take the square root of 9, you get 3. If you take the square root of a squared, you get a. So 3a times itself would be 9a squared. 4b times itself would be 16b squared. So completely factored, this would be 3a plus 4b times 3a minus 4b. Couple more of these. What if I gave you 2x squared minus 18? Does anyone know how to start something like this? All right, very good. We have to take out the GCF first. We don't want to look to start at step 4. We talked about before starting at step 1, the GCF. If we start by taking out a 2, then we could see it's a special case. Then we could write this as x squared minus 3 squared, which would just be x plus 3 times x minus 3. Then we'll just do one more. What if I gave you x to the 4th minus 1? Oh, what squared is x to the 4th? X squared. Obviously, 1 is 1 squared. So it's the same idea. This would just be x squared plus 1 times x squared minus 1. We're not done yet, though. With factoring, even though you factored once, you might still have to keep going. You see how this is another perfect square minus a perfect square right here? We have to actually keep going. So x squared minus 1, we could write as x to the 2nd minus 1 to the 2nd, which would just be x squared plus 1 times x plus 1 times x minus 1. This is a problem people sometimes have a hard time with. They get excited, they factored once, and then they kind of walk away and they forget to finish it. All right, so we have a couple more cases to talk about. I'm going to actually do them at the same time. So we have a sum of perfect cubes, and we have a difference of perfect cubes. The formula for this is if you have something cubed plus something cubed, the formula would be a plus b times a squared minus ab plus b squared. It's similar to if we had a difference of perfect cubes. If you have something cubed minus something cubed, the formula would be a squared minus b squared. I'm sorry. Just a minus b times a squared plus ab plus b squared. I recognize these formulas are a little tricky to remember. So there's an acronym to remember them. It's called SOAP. So the letters are exactly the same, but the signs, this first sign would be the same as the original. So if this is plus, this is plus. That's one way to remember it. The O would stand for opposite. If that's a minus sign, that's the opposite of the plus here. And then this last one is always positive. So that's how we remember those last two formulas. All right, so let's talk about this. If we had, the directions are going to be to factor. And what if we were to factor x to the third minus 27? So you have to think to yourself, what cubed is x cubed? Obviously x. What cubed is 27? 3, right? So then just looking at the formulas we wrote down, it looks like this would be this third formula. What we would do is we would write the first term, same sign the second, the first term squared, the opposite sign, x times 3 or just 3 times x, always positive, the last term squared. So the final answer for this would be x minus 3 times x squared plus 3x plus 9. What if we had a problem like this, where it's 2 x to the third plus 16. Yeah, so we're going to factor out that 2 first. And then think, x to the third is really just x to the third. 8 is what to the third? 2, right? So according to our formula, we're going to write x, same sign, b, times x squared, opposite sign, 2 times x, and then always positive 2 squared. So this would just be x plus 2 times x squared minus 2x plus 4. All right, what about something like this? What if it's 27 m to the third minus 64 n to the third? Try to figure out what cubed minus what cubed, and then fill in the formula. So 3 to the third is 27, 4 to the third is 64. We had m and n. Now we're ready to go. So it would be 3m, same sign, 4n. Then we're going to put 3m squared, opposite sign, 3m times 4n, and then plus, always positive, 4n squared. I did write this incorrectly on purpose, though. What am I missing from that second parentheses? We're supposed to square the first term, and that's what I did. I wrote 3m squared. Why is that incorrect? No, so it has to be the whole thing, right? So you're squaring the entire 3m. Same thing with the very last term. You'll have to square the entire 4n. So this would be 9m squared plus 12mn plus 16n squared. Just one other little thing. I just want to show you a little shortcut before you go. There's something called a perfect square trinomial. You don't have to know this. You could always just do this using just regular trinomial factoring. But a perfect square trinomial says that there's two of these. If you have something squared here and something squared here, and 2xy in the middle, this would just factor to be x plus y squared. And again, you don't have to do this. You could just use regular trinomial factoring. I just wanted to show you in case you like shortcuts. Another kind would be like if you had x squared minus 2xy. So if you have perfect squares on either end, you could write it like this. So I don't want to spend too much time on this. I wanted to save it just for the last like couple minutes or so. But an example would be like if you had 9x squared plus 48xy plus 64y squared. You could just do this regular trinomials with the x. That's totally fine. One thing you could also do is recognize that this is just 3x squared. This is just 8y squared. And this is just 2 times 3x times 8y. If you recognize that, you could just factor it very quickly and say it's 3x plus 8y to the second. So if you recognize this first term is a perfect square, this second term is a perfect square, and the middle is 2 times the first and last, you could just throw it into that formula. All right.